Welcome to Cloud Native DevOps and Docker Talk. This week, I'm with my co-host, Nirmal Mehta, back in the studio. We've got two guests from Microsoft, Kühl, a principal technical PM, and Jose Blanquicet, a senior software engineer. Both of these gentlemen are from the Inspektor Gadget team. No, this show isn't about Uncle Gadget and his robot insides, which was one of my favorite shows in the 80s. The episode is about Inspektor Gadget's eBPF-based Linux tools called Gadgets that can inspect and debug your pods at the kernel level and are centrally managed through a Kubernetes daemon set. The Inspektor Gadget team will explain why the CNCF project exists, and they'll go through multiple demos showing off how it's deployed and used. This is an edited version of our weekly YouTube live show that you can join and ask our guests questions on Thursdays at 1 p.m. U.S. Eastern at Bret.live. So please enjoy this episode with the Inspektor Gadget team. Chris, where are you coming from today?
I'm in Berlin.
Berlin, nice. And we got Jose from
Turin.
So let's get into it. Chris, why are you on this team? How did that happen?
Yeah, we had a company before we were at Microsoft, and we came in through an acquisition. And in that company, we were working with CoreOS on container things. And then the second kind of big projects that we were working with BPF. And yeah, we started Inspektor Gadget at Kinfolk, which was the name of the company. And then we've been continuing it at Microsoft.
Nice. Well, Chris, you've been around this thing for a while. Like, why does this exist? What's the original reason why Inspektor Gadget had to come to light?
Yeah, so I've been around from the very beginning. So this was Aubyn's creation, Aubyn Krecki. He was my co-founder. We had these projects in the community, for example, BCC, which is called the BPF compiler collection. And that was like a collection of tools that you could run on a Linux machine. And you can still run it, and that's a very popular project still. But we were looking at, okay, how can we bring this to Kubernetes? And with Kubernetes, you have to basically, instead of loading on one machine, you have to load it on all the nodes. And so it started as a project to basically bring the BCC project to Kubernetes, because basically there was a collection of many, many tools there and that are very useful in many, many different ways. And we have things to measure performance, to measure policy violations or auditing. You have things to measure network traffic. And we thought we would bring that to Kubernetes, and that's how it started.
So Kubernetes doesn't do any of this out of the box. What's the synergy there? Like, is it because we had Kubernetes and we needed some of this inspection and observability, but there was really no other way to do it at the time? Or,
well, I mean, there's a lot of ways to do observability, right? In the past 10 years, projects like Falco and Cilium and many other projects their foundation about how they do things is using BPF. BPF is this technology that runs in the kernel, right? And it can give you a view of the system that is not what you can normally get from user space systems or facilities. And it is also often very much more performant because you can actually you're collecting the things inside the kernel without doing context switches, which are very expensive. And you can even do filtering in the kernel. So filtering before it actually comes up to user space. So it's basically all these tools that you can do a bunch of things with. And it's like, it was kind of a potpourri of tools, right? A potpourri of things you could do. And it's not only focused on like one use case, it's so many. And we were thinking, let's bring this to Kubernetes, see what people do with it. And that's what we've continued to be doing. But we really evolved the project, and especially in the last year since joining Microsoft.
Right. And there was a conversation when I was first learning about why this tool exists around the challenge of each one of these things could technically be their own tiny tool that you put on a Linux host that happens to be running Kubernetes. But that would be a lot of different tools to install. And that would be a lot of work outside of Kubernetes. And one of the things that we all love now about whether it's Kubernetes or we got some Docker Swarm fans in the audience, like we've got all these orchestration engines now, but the idea is that we can focus less on the OS and installing things and managing versions and updating and all that stuff on the OS. And we can focus more on a higher plane where the applications live. And is one of the advantages here with Inspektor Gadget is we can do these things in a more organized fashion. Like, does this become sort of an installation and enabling tool plane for a whole bunch of other, like you mentioned, all these gadgets, I guess. So that's what we're calling as gadgets, right? Each one of these has its own purpose, right? Mm-hmm. This thing runs in cluster, right? Like this thing is actually allowing us to do more on top of it.
Yeah, talking about the kind of the value add of what Inspektor Gadget does. This information you get from the kernel has no view of Kubernetes at all, right? And so this information that you're collecting is kind of raw data, right? It tells you a mount namespace, C group, etc. And so one of the things that Inspektor Gadget not only distributes this around your cluster, it also does what we call enrichment. It takes that information, it talks to the Kubernetes API, it talks to the Docker or whatever container runtime you're running, and it maps that low-level information to high-level information. So this kernel data is then enriched with the information that you need to understand your system. And so I guess what you're talking about is these higher-level concepts. Really what Inspektor Gadget does, it takes a tool that is fundamentally a low-level tool, and it maps it to these higher-level concepts.
So who's the audience for Inspektor Gadget, right? We have a lot of, like Bret mentioned, we've had a bunch of solutions over the years that have used eBPF in different ways. What's the audience for Inspektor Gadget? Is it the platform engineers like myself that are trying to get observability or security or the features of eBPF or those higher level tools? Or is it somewhere in between?
Yeah, I think it's at this point, it's probably good to mention not only where we started, but like where we've been going to, because that's really this evolution that we've taken over the last years is about serving multiple types of users. When we first started, it was pretty much purely for somebody who wants to debug and troubleshoot a Kubernetes cluster. Now that story is vastly expanded because you can still do that, but now there are mechanisms for sending that data not only to your console or to a JSON file or a JSON output. You can now send that to Prometheus, and we're working on other OTel exporters. So you can basically start up a tool, and we have a demo for this later, I think, where you basically can start it. It's sending your metrics to Prometheus, and at the same time, you can say attach to this tool, and you can see it on the console, like if you're doing debugging. We serve the use case of interactive debugging, like real time. We serve the use case of collecting things and sending them to your metrics server or your log server, etc. But really interesting, and the way we've evolved the project over the last, I guess, year and a half or 2 years is the BPF programs, which we call gadgets, were originally embedded into the system. And we still have those around because we don't want to just drop them when we know folks are using them. But what we've done with I think 2 releases ago now, and this is something that has been there behind an experimental flag for quite a long time, is that we've taken those BPF programs and now we've broken them out into their own artifact, basically. And they're packaged as OCI images, very similar, basically the same way containers are nowadays. And what that's done, it's decoupled the BPF logic from the project itself, so you can actually develop these externally from the project. And so we really refer to Inspektor Gadget now not as only a collection of tools that you can use directly, but it's also a framework for doing this. And so in that case, it's kind of for platform builders or people who want to add some additional functionality using BPF, whether they want to create their own or just take something off the shelf and build their platform off of this. And we have folks like the Armo folks, Kubescape, for example, uses this. Internally, we have the Microsoft Defender for Cloud. Folks use this in that fashion. But then not only that you can use the system you can kind of feed it into your system. What we also have is basically you can wrap almost all the functionality in a Go library and use it internally to your application. And so what we've tried to do is take all of this boilerplate stuff you have to do when you're dealing with BPF and observability and package that. And so we have the system where, you can write your gadget or pull a gadget off the shelf that we provide or somebody else does, load it. We pull that from the kernel. And then we have these different phases where we do all that stuff that you would normally have to do, and we just do it for you. And so that's why we call it now a set of tools and a framework.
Got it. So initially it started as a way to standardize, build this framework for the tool builders, the builders that are actually utilizing eBPF and avoiding having to replicate all the minutia of interacting with the kernel, loading the eBPF modules, standardizing that, creating these images. But now, because you have these gadgets now, it's almost like you're going up the stack, right? You're able to provide this tool to the platform engineers and also maybe even to the application developers to hook into the data streams that are coming from eBPF or your gadgets, right?
Yeah, the thing is, BPF is hard. Some people can write BPF programs.
That's a massive understatement.
I mean, it's kernel engineering, right?
Right.
And so what we thought is that if we package these, have all this stuff taken care of, people can use these more directly because it is a tool that you can just use. But really, I think it empowers a lot of people building platforms to use BPF without having to write them all themselves, because they'll have a collection that they can just pull off and use them as they want, right? They can take some of them, they can take all of them, they can take one of them. It's up to them, really.
Awesome.
I think you had a couple of diagrams that might be good to pull up to get a conceptual overview, because I think one of the unique things here is that we're talking about things that are actually operating at the kernel level in a lot of these cases, but we're orchestrating it through Kubernetes, which traditionally we think of Kubernetes as for the apps that run on top of it, not necessarily for doing the low-level stuff on the system below it. And as someone who has to I lean on the ops side, so I have to deal with teams where we're still stuck in Terraform and other ways to manipulate OSs, get Kubernetes installed on it. Any other agents that maybe aren't Kubernetes friendly, we have to put on there. It's still low-level systemd kind of stuff. And there are times where I just want all that to go away. In general, I just want all that to go away. Because we have this API that people have described Kubernetes as the data center API, and we have this thing that could maybe be the one way I manage them all once it's on there. And we've seen other attempts at tools now that run on top of Kubernetes, but actually manage the things below Kubernetes. Is this something where once I find a reason to use one of these gadgets, I'm basically going to be installing Inspektor Gadget, the platform, on each of my clusters, and it's going to hook into each node? Is that kind of how this all plays out?
I mean, yeah, it has to be running. The way you kind of deploy it is, or if you're doing it from the command line, you would install using Crew, the gadget, kubectl gadget, which is a plugin there. And then once you do that, you can do kubectl gadget deploy, and then it'll put everything in place so that you can start utilizing Inspektor Gadget. So yeah, it does have a process that runs on each node. And yeah, that's fundamentally how it has to work.
And each of these gadgets, they're not running as pods, right? Even though you're delivering this as OCI images, they're not technically Kubernetes resources. Am I guessing that right?
Yeah, the gadgets are, because this is underneath Kubernetes, right? BPF has to be loaded into the kernel. And you can, some people have been mentioning it, and I don't know how far we should go as a project with this yet, but it's like an orchestrator for BPF programs a little bit, because you can basically say, deploy this functionality, and it'll just take care of it, right? It'll put it on the right nodes. Although I think we have a PR out to make that work 100% properly. But, it's an in-progress project. But yeah, and that's the idea, basically, is it orchestrates this BPF functionality, specifically right now for observability space. But we have some folks building chaos tools using this. So we try as a project right now to not focus on things that BPF can do things in the kernel, right? And that's what Cilium, for example, utilizes to optimize network performance. We try not to have anything in the kernel that we develop that changes anything. It just basically observes and sends the data out. But, people can do that. And if they so choose, and there's people working on a set of chaos tools based on gadgets where, not only can you insert network fault or things like that, but you can also report it, because we have that mechanism built in where you can also observe that activity, which is pretty powerful, I think.
Very cool. We do some show and tell?
Yeah, I was just going to ask Jose, do you want to show how this installation works?
Sure. Let me share my screen.
I like this idea of orchestrator for eBPF projects. Maybe we'll get back around to that in a later conversation, but that's an interesting kind of way of seeing what this project is about. So Jose, what are you going to show us?
Okay, this is a normal installation of Inspektor Gadget in a Kubernetes cluster. As Chris mentioned before, we have two parts. We have one part is the CLI part, which is the kubectl plugin. It is called Gadget, and you can install it using Kühl. And you have the second part that is the server side, which is actually a daemon set that runs on the cluster and will install one single pod for each node. And that pod will be the one in charge of installing the gadgets inside the node and collecting all the information and send it back to the client. So we are running just one pod for each node, and that pod will be in charge of the installation, putting the eBPF program in the kernel for that node, and then send back the information to the client. So here I deploy Inspektor Gadget in the cluster, and now what you can do is run a couple of gadgets just to show you an example of them. We have in the video an example using trace DNS gadget. It is, for instance, filtering by a pod name. So you are like, even if you are using something that is low level, as Chris mentioned, low level like eBPF, we are putting the things in a situation that you are just looking at the high level resources. So you don't see here anything related about eBPF. You see here filtering by Kubernetes resources. You have all the events that are happening at the kernel level, but they are associated to the node where that event happened, to the namespace, the pod, the container, and then we have the actual event that happened in the kernel. So this is an example. Yeah.
So I don't need to know anything about eBPF, but this gadget, like this trace DNS, like if I have to troubleshoot my pod sending out a lot of DNS requests or not able to resolve something, I could get Inspektor Gadget on my cluster. I can pull this gadget and run it and use that tool without having to know anything about eBPF or what it's doing underneath, correct?
Correct, exactly. That's one of the, let's say, the group of people we are targeting the project, because these kind of users are just gadget consumers. They don't care about eBPF. They just using the gadget that we are already providing, so they can just take advantage of the gadget we already created, the use cases they are covering. DNS is one that, it is always DNS.
Yes.
So you don't need to know anything about eBPF. So this is one of the examples. And let me show you another one that is Top TCP. That's another one that's pretty much, I like it a lot because it will show you the activity, the activity of the TCP connection that you have in the cluster. This time I will filter by a namespace. So all the activity for each TCP connection that you have in that namespace. And it will be sorted by send and receive. So the amount of bytes they are sending and receiving. So you will see the top X connection that are generating more activity on your namespace or your pod or the filter you use.
So like this is at the namespace level. So one thing that you mentioned is that the eBPF at the kernel level does not know anything about Kubernetes pods or namespaces or any kind of Kubernetes resource. However, this tool does. So is Inspektor Gadget doing that? Is the gadget itself like the correlation between the data that's coming from eBPF and the Kubernetes resources, essentially? Is it doing that mapping?
Yeah, it's not the gadget itself. It's actually the framework. The process is called enrichment. The enrichment that Chris mentioned before. So we are taking these low-level events and associating them to the high-level resources like the namespace, the pod, and everything.
Yeah, I think one of the interesting things, though, is that we often talk about enrichment only going one way, like collecting the data and then sending it out with this information, whether it's displayed on the CLI or in your data collection mechanism. But as Jose demonstrated, it also goes the other way because it allows you to filter on these high-level resources. So it's and that filtering, this is kind of important because one of the reasons people use BPF is because it's very performant. And as I mentioned a little bit earlier, it does this filtering in the kernel. And so when we can, and that's not always the case, but when we can, we utilize that filtering in the kernel. So you get really that performance gain from BPF, even though you're still using these high-level concepts that you understand.
So the framework is providing that kind of standardized enrichment process, two-way enrichment process. So that is that essentially so that the filters and the correlation between these different resources are consistent, so that the filtering or querying or other higher level things are consistent across these gadgets? Is that the aim with that?
What I would say, one of the things is, we've broken these gadgets out into their own thing, these OCI images, right? And what we're doing there, we're encouraging folks outside of our team to create these. And we've already started to see the first ones. We just finally got this out of experimental. And so when we were going through this process, we were like, okay, you want to motivate people to do this. And what can you motivate them with? basically by taking care of a lot of that stuff that you just don't want to take care of. And one of those things is enrichment. Like there's a lot of BPF tools and they all have their own way of doing this, right? And so we're trying to keep this consistent, not only for us, but for anybody who wants to do this data collection with eBPF. And that's kind of the power of the framework, right? And so adding value to people who you're asking, like, for who's this for? It's also for those folks who do write BPF and want to get this in more people's hand with all this kind of built functionality.
Yeah.
I just wanted to add something. Where there is this second group of audience that will create their own gadgets. And when they are writing their gadgets, we are providing also some APIs that will allow them to, okay, you want to filter by container, you want to filter by this high level, use this API. So yeah, they are writing their gadget and they don't need to know all this association. We just providing the API. They say, okay, I want to filter by container. So use this API and then go ahead and do all the operation that you want to do only on the containers that you are interested in.
Interesting. Are you having conversations with other CNCF projects that maybe want to utilize eBPF or are using eBPF right now to this framework?
Yeah, Kubescape is already using it.
Okay.
And so they use this for their basically, as I think they call it, a sensor. At least that's what the MS Defender folks call it. So it's also being used there in commercial products. And then we have other folks we're talking to. I don't know if I want to call them out because it's like early, But yeah, I mean, we're interested in our basically mission here is to not only allow people to use BPF directly as a tool, but also utilize the framework. And we want to understand more people's use cases so that we can fashion it in a way that fits them. I think right now there's so many different ways to use it. And I think one thing that we haven't really mentioned here, it is not only, and this has happened in the last, I think, year or so, and Jose was driving this, it is not only for Kubernetes, it runs also directly on Linux. And that was actually the reason we actually want to support that was actually we had folks asking us, okay, we're running on Kubernetes. What if we want to actually debug Kubernetes? And so basically go underneath Kubernetes. And so we have a tool called IG, which is also the tool used to build gadgets because we have a build system for that too, which makes it really easy. And so you can use Inspektor Gadget not only on Kubernetes directly, but you can also use it on Kubernetes node underneath it. And it'll still understand Kubernetes and containers and all that other stuff because it's still talking to the API, which is pretty powerful. So
actually, that I remember there is a use case that what happens if the API goes down? So we have the possibility to, if you can run the IG binary in the node, you have the permissions to do that. You will be able to have all the understanding of Kubernetes, but we take that information not from the API server because it is down, but from the container runtime. So we are still able to filter by container. You are still able to see the containers because all the containers are still running, and you try kind of debug Kubernetes itself, completely decouple for Kubernetes. So that's a super interesting use case.
Yeah. So we had one question, which is in Inspektor Gadget, is there support for Windows nodes? So you just mentioned Linux, but
no, we do not support Windows nodes. It's kind of funny because we're a modular system, and as long as the data gets fed in and it fits what it expects, I don't think it would actually be too hard to fashion it in a way that it would just, because one of the things we've done, like this was like a major effort to create this framework in a very modular way, so that basically we have when the data goes through, it's in stages, and so it's decoupled. And so I think it wouldn't be too hard if somebody actually wanted to do that to plug it in to the system.
Interesting. Now, I know it
wouldn't be a complete rewrite if you were going to put it on Windows.
No, that's the thing. I think it would just be an interface to conform to. I think it would be pretty easy.
just
actually.
translating
the Win32 or the whatever they're called now.
Yeah, whatever is the part that is actually getting the data. I think that's pretty much. And then there's translation loading it, but yeah. I think we could even make it so it's so you can actually even do it outside of the project. Like we're going to make a hook or something for that.
There was a blog post around observability, and that's highlighted as one use case here. Jose, do you want to show us what that looks like with Inspektor Gadget?
Sure. Let me share again my screen.
Yeah, while he's doing that, I'm going to precede the next question real quick. I'd like to go down a scenario of the OOM kill tracer, because I think that's, to me, like if you've run a production cluster, you have probably had to fight an OOM issue out of memory, for those of you lucky enough to not have to deal with that on Linux. And I would love to walk through a scenario where we're using that and gives people an idea of that. But all right, what are we about to watch?
Okay. So here in this example, it will be different. We will not use Kubernetes, but we will use two systems. I mean, this is the system in this tab. This is the system that we want to monitor. So here is where we deploy the daemon and we expose an IP and port where clients will get connected. And this is a particular flag, this OTel metrics, which is the one that will enable an OpenTelemetry listener endpoint that is compatible with Prometheus. So we will be able to export the data that the endpoint where Prometheus will get the data. So this is the daemon. We are running this in the system we want to monitor. And this is the client side. This client is Linux, but it could run also on Mac. So this is the client side. It's called gadgetctl, the binary. It is connecting to the server. And in this case, we will run the profile block.io gadget. This gadget will collect the latency of the block.io operations in the whole node. Then we will export this information with the metrics. So we want them to go to Prometheus. We just are providing a name for that is demo block.io. And here, the last flag is a very interesting flag because let me do something. The last one is a very interesting flag. So the detach is that by default, as I showed before, by default, all the information will be printed in the console when you run a gadget. But sometimes in this kind of situation, when you are running observability session, you don't want your terminal to get blocked running the gadget. You want the terminal to just finish immediately and you put the gadget headless running it on the system that you are monitoring and just you go on. You continue doing whatever you are doing. So when we are using this detach, look that the client finishes immediately. It only installed the gadget, but you are already done on the client side. You can see all the gadgets that are running in the background on the server. And now you can have this observability session running. So if I go to the browser, I can already see the metrics that are being exported. We have the histogram. That is the way the latency will be presented. But let's use this with Grafana that will generate the graph of the histogram because the histogram is not readable like this.
Yeah.
So we can use Grafana to take the information from Prometheus and generate the actual histogram. So let's create this. The data source will be Prometheus. And here what we'll do is just use the information, the buckets for the histogram. The filtering will be the name we give to it in the CLI. So demo block.io was the name. This is a heat map. So let's the kind of data we have. Yes, configure it to see some data. And this is a histogram. So let's use a histogram and look at the information. So now you have here the amount of operations that the latency for that operation fall into these intervals. So you can see it will continue increasing, and you can see what is the interval where most of the operations are falling.
Awesome.
But,
so this doesn't have anything to do with Kubernetes at this
Nope.
at this level. Exactly. Okay. Keep going.
But it basically works the same way with Kubernetes.
Yeah, exactly. Yeah. We are monitoring here a Linux host, but this is just counting everything. What about if you want to see how they change in time? So using Grafana provides this kind of graphs that are called heat map. So we can take the same information, exactly the same that we did before, but this time the operation will be a rate. So we see how things change over the time. The configuration is exactly the same, but this time we will try to use a heat map to see the changes over the time.
Awesome.
Yeah.
So with those two tools, just to recap,
Yes.
the first step was running the daemon, the IG daemon. Is that the thing that is setting up the framework and setting up the hooks into the kernel? And then the second one was running that profile gadget, or the first one was a gadget, or are they both gadgets?
No, it's like in Kubernetes. The daemon is the one that is in the system and it will be waiting for the client to ask him to install the gadgets. So from the client, you said, okay, please run this gadget. The daemon is waiting there. They download the OCI image, install the eBPF program in the system, and start exporting data or send it back to the client if it is the case.
Got it. So that profile block IO was like the gadget in this case that you were loading, and it was focused on collecting or filtering or using the Inspektor Gadget framework to collect the block IO data and then expose it as Prometheus metrics.
Exactly.
At that endpoint.
And just for the demo, I ran a container that was generating a lot of block IO operations to stress the system and to see how actually the graphs show the changes.
I like the stress. I have my own repo just for the stress command.
All of us that do demos, we all have all those stress tools. Yeah.
And now look at the heat map. You have this one single place where exactly there was a change. Something happened there. You have the heat map and something happened there because it is completely different, the amount of the rate. And also on the histogram, the amount of operations change.
So this is awesome for troubleshooting, like this specific kind of environment where you have a Linux machine with some processes, some containers, trying to figure out what's going on. You can quickly visualize and profile and get that really detailed and rich data from the kernel, from the operating system, right?
Right, exactly. And this did the same thing. You can do it in Linux hosts or in Kubernetes, the same functionality, but we wanted to show both of them. But this is something very interesting because we are running right now an observability session. You are running in the background. You are just using Prometheus to export the data and using Grafana to see the data. But if maybe you want to see actually in your CLI what is happening, the normal output that the gadget has, you can attach to that gadget from the CLI. So you can look for the gadget and you can attach to that gadget. And what will happen will be that in the CLI, you will be able to see the output that you normally will get when you run the gadget.
Interesting. So you can plug into the matrix here.
Yeah, exactly.
And get the raw feed.
Yeah, I mean, it basically demonstrated it's coming all from the same place, right? And Inspektor Gadget just allows you to view it in different ways, and you can do it in a single way, or you can tap into it while it's running here. Yeah, we try to make it very versatile. So.
Yeah, it's a little bit, it feels like it's a little unopinionated. It's like the Docker, what is the old adage? Batteries included, but swappable. It feels a little bit like you want it to go to a metric system for storage. You want to see it in a console. You want to look at it remotely. I should just shameless plug, but always bringing it back to me. If you're interested, if you're doing your own stuff and you're interested in stressing tools, I have several examples on my GitHub, including the stress utility that we just ran. You can actually run it as basically it gives you commands automatically in different image tags so that you can put it in Kubernetes, because you can't, with Docker, you can run a bunch of stuff with the command line, but it's not as easy in a Kubernetes deployment to customize. So it's just simply a quick way for you to be able to deploy something to Docker, Swarm, or Kubernetes and have it stress based on your requirements of memory and CPU. Anyway, I've done that a lot for like on screen and on stage stuff.
Speaking of stress, there's the OOM. You were mentioning, Bret, the OOM killer, right?
I mean, I don't know how many times in my career I've had to fight with OOM. I mean, certainly way more since we've had containers, because we're actually using C groups and limits now. Like, we're not just letting something overrun the whole system, which happened all the time before we had containers, because people didn't know about C groups or didn't know about limits, except maybe if you're running like Java and you threw in an option to limit memory. But this is why it was always hard to run MySQL and Apache or MySQL and PHP all in the same system, because the database would take up all the memory and then you'd crash and die and burn. So we'd all end up with separate systems, one for the website, one for the data. Anyway, it's been a journey with out of memory. And out of memory now is something, if you go and you listen to my courses or you listen to Nirmal and I talk, we are always recommending limits when you're whether in Docker, Swarm, Kubernetes, Compose, Nomad, like I don't care what your orchestration system is, there's probably some way to set reservations and limits, and they will probably bite you at some point because you did so. Doesn't mean you shouldn't do them, but it does mean that you will have challenges because you'll hit limits that you didn't realize because this is how it always happens for me. Someone has a module or in their app that creates a PDF report that is way bigger than they ever predicted, or it ingests a PDF for OCR scanning bigger than you ever predicted, and someone threw you a 5,000 page. And then it consumes all memory, and then it crashes, and then it repeats, and it gets in a loop. And then the way you find out the first time in production is typically, because you're not aware of this and you're not monitoring it, is you find out that's one of your customers, you get notifications from your customers that the best monitoring system in the world. And then you go down this rabbit hole of troubleshooting what is out of memory. How does it even work? What are my limits? How do I notify myself? And my experience since Kubernetes is coming out, I'm getting to the point here. Kubernetes has events for out of memory, but it's only on pods. So things that Kubernetes isn't managing, I'm not going to get those alerts if I'm just focusing on Kubernetes events. So my assumption here, and this is leading up to the question, my assumption, if I'm looking at this option here, that this is running in the kernel for everything on the OS for out of memory. Is that true?
That's true. So you will be able to catch also processes inside the pod that runs out of memory.
Yeah.
So not only the pod, the whole pod, that is the information that Kubernetes gives you.
So if I had things running outside of Kubernetes, this would pick that up as well?
Yes, also.
Okay.
Yeah, and it'll tell you if it's running in Kubernetes or not, because you would either get that information or not that's associated with Kubernetes.
Nice.
Yeah. So this is very helpful. And especially if you're running Java workloads, this will bite you eventually, for sure.
Or a database of any kind.
Or yeah, a lot of different workloads on Kubernetes, or just on the box, especially if you have a lot of these other agents or other things running on your node. I know there was one last demo. Jose, do you want to get into that last bit here?
Sure.
And this is, we've kind of covered some of the different folks that might be interested in using this, right? A value proposition from like someone who's just trying to troubleshoot what's going on, like we just talked about, or someone who's building tooling and wants to use eBPF and you have a framework there. I know over the last decade, and Chris, we were a little bit talking about this before, but over the last decade, there's been an increase in eBPF-based tools or usage, but it does hook into the kernel in the operating system. So there's a level of trust that you have to establish, right, with wherever you're getting that eBPF tooling from or that BPF hook from. And that's kind of scary to a lot of like the platform engineers and folks that are operating these systems. So how does Inspektor Gadget help with that, Jose and Chris?
A lot of people, the first thing they say when they talk about BPF is like BPF is safe. But what does that safe mean, right?
Yeah.
What the safety in when they talk about that in BPF terms means that it is they're comparing it to kernel modules, whereas kernel modules could access things and crash your kernel. And BPF is from, I'm not the one who did the verification, but it's supposed to be mathematically verified that it cannot crash the kernel and it is safe. And there's basically, when you compile a BPF program, you can't just do everything with a BPF program, like loops are limited, for example, because basically it goes through a verifier to make sure that it's not going to consume all your memory, et cetera, et cetera. However, like you're saying, you're loading things into the kernel. And, and what I was talking about earlier, you can have things like chaos tools that are injecting things, or it could be malicious, of course, or you have things that are just doing the right thing, but they're also changing your kernel. Like Cilium does it in a good way, right? They're maximizing the speed of your network connections and things like that. So yeah, you should be very aware of what you're putting in there. Actually, I can share a graphic. Maybe that'll help.
I've heard like over the last year, just in a lot of the conversations around eBPF, this is like a key concern, right? Like as adoption increases, like just even there's no like layer of trust or trying to figure out what's going on, where like there's a lot of goodness that we can get from the eBPF tools, like you just showed, but as someone that has in the past and has to like validate and know what they're running and responsible for being on call when things happen, I don't know, like it's kind of scary to just adopt these tools that hook in.
Yeah. So this graphic here shows, because so what we did, like I was saying, one of the fundamental things we did is we took the gadgets out of our project where we controlled everything. Basically anything that was going in, we could see everything, we could audit it. In the most cases, we actually created it. And so at least we trusted it, and we hope the community trusted us, right? And obviously it's open source, you can see it all. Although I don't have fantasies that everybody goes and reads all that. But so what we did when we introduced this mechanism to have gadgets that live external from the project is we needed to have mechanisms of how to control this. And so we have a few mechanisms. You can basically sign, and I hope this is not too small for folks to read who are actually doing it.
You're good.
But the idea is that we have our project registry, and that's where we have our gadgets, and you can fetch those. And you don't have to trust us, but we think we're fairly trustworthy. But you can also have third-party registries that you pull your gadgets from. And then you can have your own registries that you pull your gadgets from. And so what we had to create is a safe way to do this, because in some instances, when you're just playing around, maybe it's okay to load things from external. But when you're actually using this for production, you want to have guarantees that somebody's not just going to pull things down. And so we have basically various lockdown mechanisms. We have a mechanism where, like, an administrator, for example, can install a certain set and then say, don't allow any more things to be pulled, only use what's there. We have the mechanisms where you can say only things signed with this key can be pulled down. And then we have the mechanism that says, okay, trust this whole registry, right? And by default, we trust the project registry. And I think for anything else, you need to make sure that you either say you trust it and you don't want to look, or you you apply basically their public key. So yeah, that was very important for us. And having this mechanism, we did not take it out of experimental until we had this mechanism, because it's really vital when you allow this level of flexibility that you also have a good level of control.
Awesome. Jose, do you want to show us what that looks like?
Yes. So when you finish creating your gadget, you need to build it and push it to a OCI compliant registry. This is the normal process that you will do. And then using that, you will be able to use your gadget in a Kubernetes cluster. So we install Inspektor Gadgets in a cluster and then try to run the gadget that we just push. You can see that it immediately will give you an error saying that the signature wasn't found. We will allow only to run gadgets that has been signed, or if you explicitly said don't verify things because maybe you are debugging and you are running something test very quickly, or you specify the repository from which you want to download it. So just for the demonstration, I will show that if you disable the verification because you are debugging and running things, you will be able to run your gadget. Instead, if you don't but look that the verification feature can only be disabled by administrators. So only the people that have the permissions to deploy and undeploy Inspektor Gadget will be able to disable these kind of features. So
awesome. So there's a level of control there.
Exactly. Look that you will be able to run your gadget. You will have a warning saying that the verification has been disabled. But of course, this is not in production. This is not the recommended way. The recommended way will be that you need to sign your gadget, use the key pair, and then tell to Inspektor Gadget when you are deploying it, okay, you will be able only to run gadget with this key. We are using cosign to sign the gadget. This is just an example to sign the gadget with cosign. You are passing a key, your private key, run it, and then this command will sign the gadget and push it to the registry. So at this point, when you will try to run the gadget, you will be able to run it because you are telling to Inspektor Gadget that look at the command. Let me show the command. When you deploy,
I just noticed the undeploy.
Yeah.
I've never undeployed before. I like it.
So now when you deploy, you are passing the keys that will verify the gadget. So my key and the Inspektor Gadget key to run also the gadgets provided by the project. So now when you deploy in this way, you will be able to run the gadget now that has been signed. This is the correct way to do things. What we encourage people to do.
Yeah. So this is like the platform engineering team can ensure that like not just any gadget out there can just be run on a node in your cluster. And likely in production, like you mentioned, like having your registry, you'll likely pull from open source projects or verify and then put them on your registry and then only sign those gadgets that you've verified and then only have your commands with your public key. running on the cluster, correct?
Yeah, exactly. And signing the gadgets, you are being sure that the integrity, the gadget wasn't modified, and no reputation. So you know who created the gadget, who built the gadget, or at least who signed it.
Awesome.
And if you're building an app, that utilizes Inspektor Gadget, then very often, it's not really flexible what you want to do. It's like, the gadgets that should be there. And so being able to lock that down and define it is crucial. But yeah, one of the cool things we're going to be doing, I think in the next release, is having basically a declarative way to do this. So you would basically have a YAML file that defines one or more gadgets and has the parameters so that when you do this run, it's not like a long gadget, CTL or IG or kubectl gadget command. It's basically kubectl gadget -f for file, and you give it that declarative file. And that basically then defines how you want everything to run. And this is really great for when you want to check this into your Git repo as part of your project.
Yeah. So then this enables you to use like GitOps or Argo or your other deployment tools with Inspektor Gadget, essentially.
Yeah.
Awesome. You already segued into one of the questions we got. What's on the roadmap for Inspektor Gadget and platform support like Mac OS and Windows? And I think we addressed the Windows side, but yeah.
We do support Mac OS and Windows in that you can access Inspektor Gadget when it's running on on Kubernetes, or when it's running on a Linux node. When it's running on Kubernetes, you use the kubectl command, kubectl gadget, right? And you can run that anywhere. We have binaries for Mac or Windows or whatever. And then when you're running IG as a daemon on one or more hosts, you can use Gadget CTL. And Gadget CTL is just a client, similar to how kubectl gadget is. And it just basically talks to it via its API. And those two programs kind of share a lot of code, and we're considering merging them together so there's less confusion. But yeah, the two clients run fine on pretty much all platforms. They're just Go binaries.
Awesome. And what's on the roadmap? What are some highlights?
Yeah, we have a lot of stuff to, like I was saying, for the full metric support. We have some PRs landing that allow better running headless a little better, because there's certain use cases that we don't cover yet, but that'll be covered, if not in the next release, and the one after that before KubeCon. And so then I think we're set up very well for that. Adding this declarative way to run gadgets is very important for us, to what I was just explaining. And then, addressing a lot of the paper cuts that come along with like introducing such a big change we had. But some of the things we're doing are like improvements on how people can access this. And what I was talking about earlier, adding value to the creation to motivate folks to create their own gadgets. So now you can utilize this framework, which does so much for you. But we also have tools like neighboring projects like Headlamp, which is basically a Kubernetes UI. And we're looking at having a plugin for that, so people don't even need to use the CLI. They can use basically a plugin for Headlamp, and then fully access all gadgets. Because actually, maybe I can show a slide here with what actually a gadget is made up of. Gadgets come with not only BPF programs, they also come with metadata that describe the capabilities of that gadget, because different gadgets do different things. And what we're trying to do is have a kind of a unified metadata format where you can describe what it does, and so that all those capabilities can be picked up by the framework. And one way we're using this with Headlamp is that we're describing what it can do as far as the UI, what it supplies, does it give you a histogram kind of format? Does it do more tracing? And the idea is that when you create a gadget, when we have this plugin inside of something like Headlamp, that you don't have to do anything else. It will automatically generate the UI for that gadget so that people can utilize it in a GUI and not even go to the, similar to how you're getting the stuff from Grafana, but more in a Kubernetes dashboard type of interface. And so we have a lot of things coming up like that. And we have a dedicated UI coming up, which Michel is working on, because Headlamp is only for Kubernetes, but we want to also make something like that available on all platforms, and also make it more kind of project, like developer oriented, probably a little bit. Yeah. And then also, some VS Code plugins to make developing gadgets easier, things like that. Yeah.
Awesome. Well, that's a very exciting roadmap and a lot of things. So we might have you all on again in the future to go over all these new things that you just mentioned. How can folks get started? Where should they go to get involved, get started, start using it?
Yeah, I mean, we have a website. It's inspektorgadget.io, inspektor-gadget.io. And Inspektor is always spelled with a K instead of the C for Kubernetes and the old GNOME and KDE way of naming things. Yeah, you can start there. We have the documentation is there as well, but also the repo is a good place to start. It also, of course, has all the documentation. And I think the README gives a good overview of the project. But you can always go to Slack. We are in the Kubernetes Slack under Inspektor Gadget there. And so we're always happy to help. And if you have questions, that's a good place to go. Anything I'm missing, Jose?
No. I think the documentation, the quick start is a very
And some of us will be at KubeCon. So speaking
KubeCon.
perfect in person is also good.
By the way, in KubeCon, we have a country fest and we will be there.
What is that is that a way for folks to contribute or?
Yeah, to basically get started, like you were saying, right? And not only we can help you with creating your first gadget or look at PRs, or it's basically we try to find I'm not sure, Jose, you sent the proposal. What exactly is this one going to focus on? Because, the people who come there can kind of make it their own, but you also have to go with a plan. And so,
right.
Yeah, Jose.
Yeah. The idea is that depending on the expertise of what people is looking for, they can start or have a simple issue to work on, or maybe they are already aware of eBPF and want to start creating their own gadget, just want to have some guidelines from us. We will be there. That will help in the way you want to start. That's a nice starting point, an excellent starting point. So we will be there and we will try to explain, we'll motivate people if they want to try to create their own gadget. We will show how to do that very easily. Mm-hmm. But if you maybe are not an expert of eBPF or don't want to go in eBPF side, you want just a couple of issues to start with, get familiar with the project, it is also fine.
Awesome.
Or learn how to use it on top of the API, or, we're very open for anybody who wants to collaborate.
Yeah, I'm all in on the declarative stuff. So when we have that imaginary time at the conference, I'll be all in for that. Like I'm gonna get this thing deployed with Argo CD and GitOps, all the things. That's my jams. I mean, this is great because from an operations perspective, we're always challenged by the two sides of like, I want to enable and light up everything, so I know about everything, but I also have alert exhaustion. There's too much stuff. There's too much complexity, and everything requires a different way of installing and configuring and managing. And I feel like things that are happening through Kubernetes, maybe even like you said, the YAML declarative model, like I feel like we're starting to get to a point where I can get like 80 or 90% of the things I need to do in a cluster managed a single way or a single group of consistent ways. And I love that we have all these options for like the command line, but yeah, I'm going to be YAML all the way on this thing. And I love the idea of being able to like sort of turn these almost like feature flags, turn on these gadgets one at a time, figure it out, get my alerting and my tracking over time. Maybe someday I'll finally stop having to respond to OOM errors, and that'll be because the very first one notifies me correctly. And it happens. We need better testing. Always better testing. But I'm glad to have you all on the show. I'm sure that's probably always the hardest thing for everyone is finally getting the 1.0 out the door and feeling like you have
We're not there yet. There's still quite a bit of way. We actually just had a call about that. And the way to 1.0 is basically stabilizing all of this stuff.
Right.
And ensure it supports the use cases that we want. That's why we're very interested in getting the feedback.
All right. Well, thank you so much both for being here. Nirmal, thanks again for being host.
All right. Thank you all for being on the show.
Thanks for watching, and I'll see you in the next one.